So what do you say, 3D printing? .3D printing, not the nerdiest and not the smelliest of nerd hobbies, but nonetheless a common nerd hobby. I myself, this past holiday season, picked up a new 3D printer. I had the original MakerBot clone that I might have harvested from stepper motors from a laser printer and some other stuff like that. I mean, it was just, it's honestly probably more laser printer than 3D printer at this point, but a little disappointing. But I had seen good things online about Joseph Prusa's, Mark III 3D printer. A little skeptical because the parts are 3D printed. I mean, shouldn't be that good, right? But it's pretty cheap. It's on sale. There was a coupon. I bought one. And I have to say, goodness gracious, 3D printing is a lot better than it was. I've done a lot of really, it's really mundane pedestrian stuff. I've printed cases for things, and knobs for things, and adapters for things. And like my Tesla V100 cards, I printed some blower adapters so that I can use just off-the-shelf blower motors with those, because they're really designed for server chassis, but I want to run them in workstations for a little while before I mount it. I mean, ultimately it's going to go in an epic server chassis, but before then, 3D print some adapters, and I don't have to rig anything with, foil tape or anything like that. It'll just work. But sometimes the print doesn't come out so good. Now, to be sure, the Prusa Mark III is an impressive machine. It is a seriously impressive machine. This is not a sponsored video. I bought it. I am blown away by how much better it is. I don't know if it's just the engineering or the software or a combination of both, but everything is so much better. It's faster than my old printer. It's more accurate. And the print quality is shockingly good. I mean, I would think that you would need some kind of closed loop system. And it does. It's got like this sort of PINDA sensor. I had a lot of fun putting it together. The documentation was exceptionally well put together. I mean, I knew what I was getting into, but if you had never put a 3D printer together before in your life, but you're good at, Lego or Erector sets or something, you would have no problem. So if you want a capable, first kit, Prusa Mark III, I have no reservations about recommending it. It's awesome. In fact, it works so well, I'm thinking about getting the 5 filament selector kit, because it's you can print in color, you can print in multiple colors, pulling from multiple spools. But because I've been 3D printing a while, and my old printer didn't really matter, but I was trying to figure out what happened with this print. I mean, I'm just printing in PLA. It's nothing really fancy. It looks like this is a temperature problem, but it was doing this on both the old printer and the new printer. And this particular material, I had a fresh spool of, so I decided to open the fresh spool, and I did some other prints, and those prints turned out okay. Turns out the reason that this print looks so bad is because this filament has absorbed moisture. It's been out of its, it's just laying around for 6-8 months, maybe a year, long time, don't really remember. And so what happens when the filament draws a lot of moisture, this particular filament is really susceptible to it because it's a little flexible. And because it's a little flexible, it's not the hardest filament in the world. It's not supposed to be like a totally flexible filament, but it's supposed to give a little bit so you can make things that flex a little bit. What happens is that filament draws more moisture than most other kinds of filament. And what happens is when the hot end goes to deposit it, the moisture evaporates. And so you need just an impossible amount of heat in order to keep it from doing this. But if you can keep moisture out of the equation, then you don't have that problem. So enter the dry box. I mean, everybody can just store your filament in a nice Ziploc plastic tub. They make plastic tubs that totally are airtight. This is literally a Ziploc brand tub, which will seal. But I'm lazy. I don't want to have to put my filament in and take it out whenever I need it. So there's 3D printable widgets that you can print to add fixtures to your Ziploc tote. And so I 3D printed all of these. I 3D printed some solid covers and some covers that have holes on them so that you can feed the filament through it. And it's even threaded on the back so that you can have like a metal, like the M10 metal hookup on the back or the front, depending on, I mean, you can orient it different ways, whatever you want to do. You can add gaskets to this. You can really seal this whole thing. So the idea is that you store your filament inside this thing. There's no moisture, and you can even add a little bit of desiccant to it. So I've added some damp rid here. Some actual industrial desiccant would probably be a better choice than the damp rid that I've put in here. But this thing will hold 5 spools that I can then feed through the front. And yeah, it's open. It's gonna, you know, you can, if I push down on the top, you can kind of hear it breathing a little bit, but it's really not gonna let in very much air and, you know, very much moisture in that air. And any moisture that does manage to get in there is gonna be pulled out by the desiccant. And so it was really awesome that I was able to 3D print all of the stuff that I needed for 3D printer filament storage on the 3D printer itself. I mean, a lot of the parts on the printer are 3D printed, so when there's an upgrade, you can just go to the Prusa website and download the update and run it. And if I hadn't seen the printer operating so well with 3D printed parts, I never would have believed it. It is shockingly awesome. Like, they've done everything. I mean, it's not entirely 3D printed, but it is so good that I have no, like, I can't complain about some parts of it being 3D printed. That's actually really awesome, because if something breaks or something changes or you figure out a way to enhance the design, this thing also handles filament change like a champ. So like, you can be in the middle of a print and it's like, oh, I'm out of filament. It stops printing and you put more in. It's happened twice because I've done larger prints, and it's done really well about not messing up the print, which is, again, shockingly awesome coming from older stuff. Makes me want to try other 3D printers. I don't know, it's really exciting. My 3D printing stuff is like, I'm printing, you know, pretty mundane, pedestrian stuff, adapters for $8,000 video cards, but, you know, like anything really exciting, no. But I'm excited, and I made a dry box for my 3D printer. So yeah, if you have any ideas for stuff that you want to do, let me know. I am working on a project with some people in our forum. You know, thanks W. Mary and Positron and a couple other guys in the forum. We're working on a model, some tiny little computer that's going to be awesome. So if you have ideas for stuff that I can 3D print and do a video on, and you want to hang out in the forums, definitely let me know. But yeah, new toy, 3D printers, they're cool. Basically low headache. It's also got a magnetic bed, which is like the most, like, that's, the quality of life on that is insane. Now here we are, just a scant day and a half later. This print is from the same spool that produced this monstrosity. What happens basically, I mean, this looks kind of like a temperature problem, and it kind of is when you've got moisture in there, because moisture changes the dynamic of your material. And to get rid of the moisture when it's doing the deposition, when it's depositing the material on the thing, the extra moisture means more energy is needed to get rid of it. And so you're gonna have poorer layer adhesion and whatever else, just like a temperature issue, when you've got excess moisture in your filament. You might be able to offset that with higher temperatures, but I don't know that that's really the best idea, especially with like PLA. And again, it varies from material to material, but after just 24 hours of drying out this material, the print quality is way better. Now, the print quality is still not quite as good as a new roll of filament. I'm hoping just getting it set up here where I can actually feed filament from the dry box will help, rather than just storing it in the container and then taking it out and mounting it on the machine whenever I need it. I actually want to have the filament just in the dry box and ready to go. That's why we did the modification. So I think that will ultimately work out better. And especially if you're only an occasional like 3D printer, you're not constantly printing with your machine, constantly using filament, seems like a dry box is worth it. And it's easy to do. I mean, this is like 20 bucks in parts. If you're really paranoid about sealing it, just a little bit of silicone, or you could cut out rubber or whatever you want to do to really, really seal the box. But if you just press down on the box, you can see how good of a seal that you've got, because it'll act a little bit like a bellows. You just press down on the top, and if you hear wheezing from somewhere, maybe you need a little dab of silicone, or in my case, poster putty, because I use poster putty for everything. All in all, I'm really happy with this 3D printer. I'm really happy with how far 3D printing has become. This is not really a 3D printing channel, but I could definitely see 3D printing helping me in the various projects that we have going on here at Level 1. So, yeah, that's exciting. What have I been missing in the 3D printer world the last little bit? Is there a deal on like Fusion 360 subscriptions? Because good Lord. You know what? Tell me what's going on in the comments below. Something. I'm Wendell. I'm signing out. This is Level 1. You can find me in the Level 1 forums. And Neat.